Everybody, so in this video we're going to look at modeling motion by integrating vectors. So we know that if we have displacement given as a vector, then this would be called r, and we can work out velocity from the displacement by differentiating r with respect to t. So velocity would be the change in displacement or the change in the position vector with respect to time. We know acceleration is the change in velocity with respect to time, or the second derivative of displacement. So using this idea, we can work out velocity if we have the acceleration. This will be the opposite of differentiating with respect to time. So this would be the integral of the acceleration with respect to time, and the displacement would be the integral of velocity with respect to time. Okay, so in this video, we're going to use these two ideas to model motion. So in example 1, we're told that a particle Q is moving on a surface, and at time t seconds, its velocity is given by this expression. And then when t equals 0, the position of Q with respect to a fixed point is -1 and 7, or -I and 7j. We've been asked to work out a position vector of Q at time t seconds. So because we want to work out the position vector, we're going to use r is equal to the integral of v with respect to t. So r will be the integral of this velocity expression. So all we need to do is to integrate the I and the j terms separately. So if we were to integrate the I term, well, we'll add 1 to this power and then divide by the new power. So we'll have 4/3 t cubed. And this becomes -2t. For our j component, we'll have 5t minus half t squared. So 5t minus 1/2 t squared. And we'll put this in brackets. But just like when we perform any indefinite integral, we need to add a constant term. So we'll have constant the vector. Then we're told that when t equals 0, the position is -I plus 7j. So we can use these to work out our constant. So if we substitute in our r value, we'll have -1 and 7. And if we substitute in 0 as t into our expression for r, then we'll have 4/3 of 0 cubed minus 2 lots of 0, so 0. And then 5/0 minus half 0 squared, so again 0, plus the constant term. So c then, as a vector, must be -1 and 7. So all we need to do then is substitute this constant back into our expression for the position vector. So r will be 4/3 of t cubed minus 2t minus 1. So this is the I component. And then for the j component, we'll have 5t minus 1/2 of t squared plus 7. And we'll close this as a vector, and we'll put in meters. Okay?